All right. Good morning again. My name is Oluwatosin Fowler, MSc candidate in the University of Regina, Faculty of Science and Department of Computer Science. Today I'll be talking about Internet of Things, IoT fingerprinting for anomaly detection. I'm supervised by Dr. Habib Lofi and Dr. Malik Mahub. I want to say thank you very much for the opportunity to be tutored by you, to be under you for this thesis. I appreciate it a lot. Thank you very much. Now I'll go into my presentation. This is my outline. I'll talk about, I will introduce the project, my proposed methodology. I'll talk about my experimental setup results, and I'll conclude and talk about my future works. As a way of introduction, there is a massive introduction of IoT devices in the market today. The reason is not far-fetched. The reason is because there is a huge demand for these devices, and that is why there is a massive production of those IoT devices. And it has been predicted by David Haynes in 2017 that by the end of this year, 2020, there will be about 50 million devices that will be introduced, into the market. And also, it's also been said by Ericsson in 2019 also that there will be about 29 billion devices that will be, available everywhere by year end 2020. But as it is today, it's obvious, from the graph just beside it, that right now by the end of this year there's going to be as much as 50 billion smart objects all around there. So what are we trying to say? That it's IoT is here and there's nothing we can do about it. Now the objectives of my research work is that we want to train different known machine learning algorithm on different subsets of features in order to predict the fingerprints of IoT devices. And also we want to be able to investigate the optimal set of features. But before we get deep down, the picture just beside it is saying that we're going to be talking about anomaly detection, and then we'll drill down into IoT device fingerprinting, and then we will talk about the optimal features of those devices. What is an IoT? In 2011, David L. Brock and Kelvin Ashton came up with an idea of Internet of Things. They are the first people that coined the word IoT, and there has been a lot of definitions around IoT. But today I'm going to be saying that IoT is defined as the interconnection of both animate and inanimate to the internet through a set of protocols for the purpose of sharing information. The major essence of Internet of Things is sharing information, and it could be between human to human, human to thing, thing to thing, and thing to things. Now IoT is applied everywhere. From the diagram in front of you there, you can see that there are a lot of places where we can apply Internet of Things. Online shopping, in-flight services, analytics, wearable technology, smartphones, music, and even in home appliances. Now, these devices have unique capacity. They are constrained. When I say constrained, the IoT devices do not have enough capacity to implement IP stacks. They are limited in memory, they are limited in power, they are limited in resources, and the same goes for their network. They are constrained. They refer them to as low power and low networks. They have very low performances, and as a result of this, they are prone to threats by attackers. And because they are scattered everywhere over wide areas of network, they are found in our homes, they are found in people's body. This is a huge threat, and that is why we are trying to talk about, anomaly detection and, using device fingerprinting to, to detect anomaly detection. Now, devices can be exploited to perpetrate several attacks, and a case in point is the Mirai attack, whereby a lot of big guns in technology, like the likes of Twitter, were down for a few hours as a result of DDoS attack in their network. Now, mobile network operators have limited control over these devices that are being, that are being deployed, and as a result of that, they try to use the network features to understand which of the devices are doing well or not. Now, that leads to anomaly detection. Anomaly is a failure caused as a result of intrusion attack in the IoT device network. And anomaly detection is a process by which we detect or the abnormal activities of IoT in any in an IoT network. Now, with reliable direct access to these IoT devices, mobile network operators resort to analyzing the network traffic generated by the IoT devices to detect the abnormalities in those network. And there are ways by which we detect anomaly. There is the signature-based method, and there is the behavioral-based. Signature-based is just based on signature of the network. Let's say, for instance, memory log of a computer system. We're talking about different things, commands, like known signatures of the device or of the network. And then the behavioral aspect is when we use the features of devices to really understand what type of device that is being deployed, and are they behaving correctly after they have been analyzed. Now, IoT device fingerprinting is a process of detecting the identity of an IoT device. And, with fingerprinting, we are able to identify new devices that are joined to the network, or the existing networks, or the existing devices that are, in the network, especially the devices that are unauthorized or that are faulty. Now, learning the normal behavior of collected data from IoT devices help us determine any deviation later on in the IoT device. This device, for our project, we are interested in knowing the identity of IoT devices. Signature based can help a little, but because the information are static, they are not changing. So it is not scalable. But with behavior, they are dynamic and they are very proactive. You are able to know, real time what is happening to any devices. So with this, we're able to, fingerprint devices, and at the same time, the behavioral baseline helps us to determine when those devices are being attacked. The fingerprinting itself has some challenges. Many houses have similar characteristics in terms of capacity, their access control, their coverage, and their shape and sizes. But diverse IoT manufacturers, just produce all these devices into the market like that, and that is why this is a challenge in the IoT network itself. Now, the contribution of this thesis to the technology world is that it helps us with the identification and processing of existing data set, related to collected traffic of IoT devices. Also, we're able to train different models with different machine learning algorithm, to be able to, on different subsets of features that we gathered, from this IoT devices. And also we are able to identify the optimal, like the minimal subset of features of these machine learning algorithms. Now, this is my proposed methodology. I'm relying on machine level algorithms, on different subset of features to predict the fingerprinting of IoT devices. The function there shows how I'm gonna do that. Like, I am gonna be using a subset of features, on algorithms, and then I'll be able to test to know which one is the optimal features. Now, this is the process that I'm gonna be following: the data processing, the data training, and data analysis. Now, in data processing, the objective here is to extract features. When I extract the features of network traces, I try to download them and then bring out the traces, and then clean it and export them to a usable format. Then I train the algorithms on them. And then finally, I now do the analysis, based on the subsets that I have grouped from the main features. This is my experimental setup, and the machine level, the tool I used majorly for this exercise or for this research was Weka. In Weka, there are different ways of training algorithms, but the one I chose was training and prediction, by percentage split. The data is split into two equal or unequal percentage for training other form of for training. So for my own case, what I did was to dissect the data into two parts, one 80% and the other 20%. I use 80% for the training while I use 20% for the testing. And these are the features subsets that I used, for my training. I trained using these following algorithms. I trained on G48, K-star, Bayesian network, and random forest. How I came about these algorithms through my research, I see that a lot of people are using this algorithm, and that's why I also use it. And I found that it was really useful. My metrics was based on precision and recall and the harmonic mean, or the F1 score. And this is the result of my experiments. If you can see from the graph, let me go to a more clearer explanation. If you can see from this graph, you will see that the precision, I have in precision, the best subsets are S14, S15, S14, and S11, and these are in J48, Bayesian network, K-star, and random forest. And the same thing for the second best subset are S15, S14, S15, and S12. With this picture, you are able to see that Bayesian network give the optimal, the best precision, and the optimal, the subset is in set of S15. I will show you what S15 is later on. And also in recall, Bayesian network give the best experimental results with 99%, and the best subset is still S15. And if you look at the F1 score also, the best subset is S15 with 99% as well. So we are able to prove that we don't need the total network features to get the optimal feature, or the best results of fingerprinting. And this talked about the complexity. You can see with business network we have 0.02, and then there is 0.02, 0.2, 1.02, and these are in in seconds. Now, conclusively, I will say that an optimized machine learning solution is proposed to fingerprint IoT device based on their traffic. The proposed solution used machine learning algorithm to for different subsets of features. The obtained results show that only 4 features, and we can see that from here that S15 time, source, destination, and info is the best subsets that we use. This guy is what we use to to predict that gives us the optimal prediction and the best result of 99%. And finally, we obtain results. The obtained results show that only 4 features, which was what I just showed you now, instead of 17 subsets, are needed to fingerprint an IoT device. The prediction results were 99%, 99.1, 99, and 99, using precision recall and harmonic mean, respectively. Now, our future work is to identify other IoT data sets and machine learning algorithms that we can use to give optimal results, and also want to conduct further experiments with other data sets and subsets and machine learning algorithm. We want to integrate this solution with anomaly detection in the future, and then we'll be able to to deal with the issues of anomaly in any IoT device network. These are my references. Thank you.